In a previous video, I demonstrated cutting 3mm acrylic using a 2.5 watt laser attached to my 3D printer. But when cutting a complex shape, such as this mini quadcopter frame, I experienced a problem whereby the outer perimeter cut would cause the entire piece to lift. Now, as this piece took 3 passes of the laser to cut all the way through, this meant the next laser pass wouldn't line up with the previous laser pass, causing some areas not to fully cut all the way through. So in this video, we'll use Fusion 360 to create our laser G-code, whereby laser cutting the inside shapes first, followed by the outer perimeter. To begin, in Fusion 360, first let's create a square on the XY plane. Starting from position 0, the size will be 200mm by 200mm. Highlight this square, right click and select construction lines. This is the size of our build platform. Now to import the exact same micro quadcopter frame into Fusion 360, it's currently an STL file, so we need to be able to convert that into a solid before we can work with it. To do that, we'll go to Create Base Feature, then Insert Mesh, and we can choose our STL file. We want to drag this file into the square we created earlier, just to make sure that the size is well within our build platform area, which it is, and select OK. Now that we've inserted our STL file into Fusion, we can convert this into a solid. To do that, right click on the object and choose Mesh to BREP. Fusion has now converted this into an object, and if we zoom in, we can see that we can actually select the individual vertices, faces and lines. Now we can choose Finish Base Feature. What we want to do here is we want to project the bottom shape of this micro quad onto the XY plane, because all we want is the bottom shape. That's all we can laser cut with our laser. To do that, from the sketch drop down, we'll choose Project, and it's asking for which plane we want to project, and the plane is the X and Y plane. From the right hand side, select Bodies and select the quadcopter frame. This does take a little while to finish, and there it is. It has selected everything on the X and Y plane for this particular shape. Choose OK and Stop Sketch. Now that we have our sketch on the X and Y plane, we no longer need the 3D model, so we can now delete it. So in the timeline, we can right click the object and choose Delete, and right click the mesh and choose Delete, which just leaves the outline from the X and Y plane of this particular object. Now we need to give this some depth, so the CAM process in Fusion 360 can work with this particular shape. To do that, we'll choose Extrude from the menu, click on the shape, and we'll extrude, say, 1mm. And there it is. There is the 2-dimensional shape of this mini quadcopter that we're going to laser cut on our 3D printer. For this example, we're going to cut that same micro quadcopter shape, but out of cardboard instead of acrylic, just to save a bit of time here. But we're still going to need 2 passes to cut cleanly all the way through this cardboard, but we can do that at 5mm a second, so that shouldn't take too long. So let me grab the existing shape. So here is the quadcopter out of acrylic. What we're going to do first is we're going to instruct Fusion to cut all these hexagonal shapes in here first, as well as the voids between the arms of the quadcopter. So we're going to ask for 2 passes at 5mm per second. Then we're going to ask for 2 passes at 5mm per second for the outside perimeter.
From the top left menu, we'll choose Cam. The first thing we need to do is create our setup. From the right hand side, the operation type will be cutting. For our orientation, we want, I'll zoom in a bit and rotate the screen. You'll notice the initial starting point is the center of the quadcopter frame. We actually want the bottom left hand side and the top of the stock. So right about there. Going to the stock tab, we want to change the stock offset mode to no additional stock and choose OK. Now we're ready to create our toolpaths. From the menu along the top, choose Cutting. The first thing we'll do is we'll actually create our tool. Our tool in this instance is just the laser. To do that, let's hit Select. From the right hand side, we'll choose Create New Tool. In this case, Waterjet Laser or Plasma Cutter. From the type, we'll choose Laser Cutter. And for the kerf width, we'll change it from the default 2mm to 0.2 millimeters. Select OK and OK. For the cutting mode, we'll choose Vaporize. That just sends maximum power to the laser, so the M106 command S255. And for the cutting speed, so this is the cutting feed rate, we want to cut this at 5mm per second, which is 300mm per minute. So we'll change the cutting feed rate to 300mm per minute. Going across to the next tab called Geometry, this is where we're actually going to select what we want to laser cut. Now, we actually want to select just all these internal gaps, so all these hexagonal shapes and the voids between the arms. If we wanted to, we could just select the top face and it would automatically select every single shape that we see here, but we don't want to do this because it's going to cut everything at the same pass, including the perimeter. So I'll unselect that, and I'm going to go through and select all the individual hexagonal shapes and even the voids between the arms. This is the power of Fusion 360, or a program like Fusion 360, which actually allows you to choose what you want to laser cut rather than just blindly following what the shape is. And in fact, if I zoom in a bit here, let me reorientate the shape a bit and zoom in up here, you'll see as part of this particular design that I've downloaded from Thingiverse, there's these couple of little voids here. There's one there and there's a smaller one over here. I actually don't want those to be laser cut out of this, so I just won't select them. Okay, I have selected all of the shapes that I want to cut as part of this initial laser cut pass. The next thing to do is move across to the Heights tab, reorientate the view so we can see what's going on. Here we want to set the top height to be 50mm. 50mm is the focal point of my laser from the top of the cardboard. That's going to actually cut this particular shape. We want to select or change the retract height to that exact same 50mm, but we want to change the clearance height to 0. We don't need that. Moving across to passes, we want to change the sideways compensation to center. And lastly, moving across to linking, we want to change the lead-in sweep angle to 90 degrees and select OK. So we have just made our first toolpath the laser is going to cut all the shapes that we've selected at 5 millimeters per second. But it's only going to do that once. We want to do this twice just to make sure that we're cutting right through the cardboard. Well, rather than creating another toolpath manually, we can actually duplicate the toolpath we've just created. To do that, on the left-hand side, we'll right-click the toolpath and choose Duplicate. And after a few moments, we've created a second toolpath which is identical to the first. But what we'll do, we'll actually name these so we know what they are. So this first one I'll change to Inside Laser Cut 1. And the second one I'll change to Inside Laser Cut 2. Okay, now we can create our toolpaths to cut the outside perimeter of our mini quadcopter frame. Again, up the top we'll choose Cutting. The existing tool is already pre-selected. We can see this 0.2 millimeter laser cutting tool is already there, so all we need to do is change the cutting mode to vaporize. You'll notice our cutting feed rate is already at 300 millimeters per minute, which is what we want. Moving across to the Geometry tab, here all we want to do is select the outer perimeter. Pretty simple. Move the mouse until that highlights and click it. Moving across to heights, we need to change this again to 50 millimeters for the top height, 50 millimeters for the retract height, and 0 for the clearance height. Moving across to passes, the sideways compensation, change that to center. And lastly, moving across to linking, we'll change the lead-in sweep angle to 90 degrees. Select OK. And there it is. That is the outside pass for the laser cut. But again, we want to cut this twice. So to do that, we'll right-click on the toolpath and we'll select Duplicate. And we'll give this a name. So just like the other one, we'll actually call this one Outside Laser Cut 1 and Outside Laser Cut 2. Before we export this as a G-code, we can actually simulate how this is going to work. To do that, highlight the top of the tree being Setup 1, select Simulate, and you can just hit play. And here we can see 50 millimeters above the cardboard, it's going to laser cut just the initial shape first. We can see down the bottom how fast this is being played. We can actually speed this up a bit. So we can see this is the first pass. Now this is the second pass. It's doing the same thing. Now it's the perimeter of the third pass, and finally the perimeter of the fourth pass. And on the simulate page on the right hand side, it is telling us the machining time is going to take 10 minutes and 9 seconds to complete this laser cut. Finally, we can export our toolpaths as G-code. To do that, on the left hand side, ensure the setup is highlighted, not one of the toolpaths, otherwise it's just going to export that individual toolpath. By choosing the top of the tree, it'll export all of this in one G-code file. We'll choose Post Process, and you want to use the Hypercube CPS file that I've created. You can download this from the Thingiverse page. I'll put a link in the description below. The only property that we need to change from the Hypercube CPS file is the start position Z. By default, I think it's 2 millimeters. We don't need to add any Z height to this because we're actually going to be starting at 50 millimeters above the piece. So just change that to 0. Give your program a name, Mini Quad, and then select Post. Save it in a directory and choose Save.
you can copy the G-code directly to an SD card or send it from a PC program just like Pronterface. So I've loaded the Mini Quad G-code into Pronterface, and you can see the travel moves that are going to be sent to the printer. That's the shape of the Mini Quadcopter, of course. Moving across, it assumes it's going to take approximately 9 minutes and 39 seconds to complete. Secure the cardboard with binder clips, or you could just use tape to secure the cardboard. Here we don't want the cardboard to move at all during the laser cutting. We're doing 4 passes and we want each pass to be bang on the previous layer. Now we want to start the laser touching the cardboard because it's going to raise 50 millimeters from the starting position, and that is the focal length of my laser, and it's going to start at the bottom left hand corner. That's where we set it up in Fusion. So I'm choosing the bottom left hand corner of this cardboard, line that up, I'll show you that. So it's resting on there, as you can see. I've got it loaded into Pronterface. Make sure you're wearing your safety glasses, of course, and choose print. It's just finished the first inside laser cut. Look up at the screen. Now says inside laser cut 2. This is the second pass. It's now cutting the perimeter. And we can see on the display it says outside laser cut 1. This is the second pass. Outside laser cut 2. You can see it's starting to lift on the corner. That's it, complete. Let's check out the results. Oh yeah, that's right through. Falls out. Of course, cardboard, easy to cut. Check that out. A few of the mounting holes need to be poked through. They just haven't fallen out on their own. Just use pliers here to poke through that one and that one. Easy. It's surprisingly rigid for its shape, or for what's left of the cardboard. This honeycomb shape is actually quite strong on this particular design. However, being just flimsy cardboard, especially out here, wobbles a bit too much. Probably not the best material for a mini quadcopter frame, but you get the idea. And Pronterface tells me this took 9 minutes and 50 seconds. And there you have it. Using Fusion 360 to laser cut this mini quadcopter frame, the inside shapes first, followed by the outside perimeter. And you can use the same techniques that I've shown in this video to laser cut this same object or other objects out of acrylic. So you would just reduce your speed from, instead of 5 millimeters per second down to 2 millimeters per second, and you'd up your passes from 2 to 3, but you'd keep the same inside shapes first, followed by the outside perimeter last. Software like Fusion 360 is the reason why owning a laser or a drill or even a pen mount to attach to our 3D printers makes it so worthwhile. Here I demonstrated full control on what you want to cut and when it gets cut. Really lends itself to how versatile our 3D printers can be. Have to clean up all this afterwards.